Right, number 6. So let's go ahead and do this. I'm going to actually follow the recipe that I gave you for this one. So I have an initial velocity of 25, a final velocity of 10, a time of 5 seconds. I don't know the acceleration. I'll assume that I don't know the final position, but the initial position I can assume is 0. So the acceleration, v equals at plus v naught. I'm going to plug in my number, so I'm going to actually end up getting 10 is a times 5 plus 25. And when we rearrange that, we're going to get a is negative 3 meters per second squared. Don't forget that squared on the units. Now, how far does the car travel on the rough patch? I'm just going to use one of the formulas. The second way of doing this is actually shown in the PDF file solution that you can find on this website. So we get v squared equals v naught squared plus 2 times a times x minus x naught. And when I plug in what I have, I'm going to get that 10 squared is 25 squared plus 2 times negative 3 times x minus 0. And when I solve for x finally, I'm going to end up actually getting here, if I have this right, so that ends up being, if I have this right, should be, I'm going to just check this. (87.5 meters per second). And then it says after the rough patch, the car's motor provides an acceleration of 5 meters per second squared, so we want to know how much it'll take us to get back up to 20 meters per second. So we're already at 10 meters per second having slowed down. We're going to wind up at a speed of 20 meters per second. We have an acceleration of 5 meters per second squared, and we want to know the time that it takes to get back up to the speed of 20. So we're going to have v equals at plus v naught as the formula we want to use. And that's going to be 20 equals 5 times t plus 10, and then t ends up being 2 seconds to get back up to that original speed.